Imagine your users typing a search term and seeing results update instantly. No lag, no spinning loaders, just lightning fast feedback as they type. In today's web apps, real time search isn't a luxury, it's the baseline for excellent user experience. But what if your search bar starts to slow down as your data grows? Or your filter logic becomes a nightmare to maintain? The secret weapon behind snappy, scalable real time search is how you structure your data, specifically, choosing between JavaScript arrays and objects for lookup filters. In this tutorial, you'll discover the crucial differences between arrays and objects when building high performance search components without using any external libraries. You'll see why some data structures quickly hit their limits as your product catalog, user list, or tag system expands, while others keep your UI smooth, even with tens of thousands of items. We'll break down exactly how lookup speed, scalability, and maintainability hinge on your data modeling decisions. If you're building autocomplete bars, instant product search, tag selectors, or filterable lists for e-commerce, chat apps, or content management, mastering these core concepts will make your features not just work, but feel world-class. You'll learn how to architect your front end for sub 100 mailers response times, giving your users the real-time experience they expect, all while keeping your code base lightweight and dependency-free. You're about to unlock practical, battle-tested strategies to make your search lightning fast and robust, whether your dataset is measured in dozens or tens of thousands. Don't miss out on future deep dives and hands-on guides like this one. Subscribe now to ensure you always have the latest front-end performance tips and real-world solutions at your fingertips. Imagine you're building a search bar for an online store where users expect instant results as they type. The fundamental challenge lies in how you represent and access your data. Should you use a JavaScript array or an object? To answer this, start by picturing an array as a row of numbered mailboxes, each holding a product. If you want to find all products whose names include phone, you must open each mailbox and check its contents. This is called iteration, and it scales linearly. The more products you have, the longer it takes. Arrays are excellent for keeping things in order, like displaying a sorted catalog or looping through items. They're intuitive for operations like mapping, filtering, or reducing. And they're the default choice when sequence matters. But for searching, especially by a unique attribute like a product ID or exact name, arrays become less efficient. Every search is a blind scan, checking each item one after the other. This time complexity, meaning the operation takes more time as your list grows, can quickly become a bottleneck when users expect instant feedback. Arrays shine when you need to preserve order, support flexible traversals, or work with small to moderate datasets. However, as soon as you need to answer questions like, does this product exist? Or show me the details for product 1234 instantly, the array's sequential nature starts to slow you down. This is why, for real-time search filters where responsiveness is crucial, understanding the limitations of arrays is the first step toward optimizing your front-end experience. Now, imagine you've switched from a row of mailboxes to a hotel concierge desk with a massive set of labeled key hooks, each labeled with a product name or ID. This is how a JavaScript object works. You walk straight up to the hook labeled Product 1234, grab the key, and access the associated information instantly. Objects are designed for direct access. Instead of scanning through every item, you use a unique identifier as a key, and JavaScript's underlying engine jumps directly to the value in constant time. This O1 lookup means that no matter if you have 10 items or 10,000, retrieving a product by its exact name or ID is nearly instantaneous. This advantage is profound in real-time search scenarios, especially when users expect results to update with every keystroke. Objects excel when your data is structured as a dictionary, mapping unique keys to values. They're perfect for situations like exact lookups, checking membership, or building inverted indexes, where, for example, each tag points to a list of articles. However, objects are not inherently ordered, and they don't support iteration in the way arrays do. If you need to display results in a certain order or perform partial or fuzzy matches, you may need to combine object-based lookups with array-based filtering. The real power appears when you pre-compute objects for the fields you search most often. For instance, if users frequently search by product name, building an object that maps names to items lets you bypass slow scans and deliver responses with lightning speed. This strategic use of objects turns your search bar from a slow mailbox check into a concierge's rapid key retrieval, making real-time front-end search apps feel instantaneous and effortless. This is the main JavaScript file that powers the real-time search demo. It imports both array-based and object-based filter strategies, connects the UI to these filtering functions, and updates the results view as the user types or switches modes. The code also demonstrates how to handle both exact and substring matches, showing the practical difference in lookup speed and code structure between arrays and objects. This file defines the dataset and pre-computed lookup structures used in the search demo. It builds a large array of product objects, a name-to-object mapping for fast key-based lookup, and an inverted index for category-based object lookups. The design demonstrates how to prepare data for both array and object filter strategies, setting the foundation for efficient search in different scenarios. This file contains the pure functions that implement array-based filtering. It features a case-insensitive substring search for filtering items by name and a direct filter by category. These functions illustrate the typical ON iteration approach required when working with arrays for search operations, which is suitable for smaller datasets or when order is important. This file provides the object-based lookup strategies. It enables direct constant time, O1, retrieval by exact name and fast group retrieval by category using pre-computed inverted indexes. When the key is not present, it returns an empty array. This approach highlights the power of objects for instantaneous lookup in large datasets and for use cases like tag category filtering. This is the main HTML file for the real-time search demo. It provides the minimal UI, a radio button to toggle between array and object modes, a search input box, and a results container. The script tag loads the main JavaScript module. The structure is deliberately simple to focus attention on the filtering and lookup logic. This configuration file defines the project's NPM scripts and development dependencies. It includes jest for unit testing and a start script to launch a static file server for the demo. This setup enables easy testing and local development without extra dependencies, supporting the library-free philosophy of the project. This unit test validates the array-based filter by name function. It checks that filtering by a substring returns expected results, demonstrating how to test ON search logic in isolation. The example uses a small sample data array for clarity and speed. This unit test validates the object-based lookup by name function. It ensures both that exact matches, case-insensitive, succeed, and that missing keys return an empty result. The approach demonstrates best practices for testing O1 object lookups. The application loads, presenting a clean interface featuring a mode switcher labeled with Array linear scan and Object keyed inverted index, a prominent search input for product names, and a section displaying live search results. The user first selects the Object keyed inverted index mode, triggering a switch in the underlying search strategy for the app. After a brief observation, the user toggles back to Array linear scan mode, preparing to compare the two methods. The user focuses on the search input and starts typing a partial product name, wireless. Instantly, the results list updates in real time, showing products matching the substring, with performance statistics reflecting the array's linear scan operation. The interface smoothly filters products as the term is typed, demonstrating the responsiveness of the array-based approach even with many items. After a moment to observe the results and performance, the user switches back to Object keyed inverted index mode without changing the query. The app adapts using the object-based lookup for the same search, and the results update accordingly. Next, the user clears the search input and enters the exact product name. Wireless headphones, 89. The search instantly narrows to a single, precise result. Performance metrics now indicate a direct O1 object key lookup, showcasing the speed advantage of object-based filtering for exact match scenarios. The update is immediate, and the user can see the efficiency displayed in the UI. The user then interacts with the category filter, selecting electronics from the dropdown. The product list immediately filters to show only electronics items, reflecting the new selection. To further refine the results, the user selects the tag bestseller from the tag filter dropdown, and the list updates again, displaying only electronics products marked as bestsellers. The changes are reflected instantly, demonstrating the power of combining inverted indexes for category and tag lookups. To reset the view, the user clears the search input, and both category and tag filters are set back to all categories and all tags, respectively. The full list of products returns, and the UI resets to its default state. Switching back to array, linear scan mode, the user clears the search input and types the substring cookbook. The results update dynamically, showing all matching products using the array's filter method. The user adds another filter by selecting the tag eco, and the displayed products update accordingly, demonstrating array-based filtering with multiple criteria. The user scrolls down the page, revealing a panel that highlights edge cases and best practices related to search and filtering, such as handling case sensitivity, avoiding key collisions, and choosing the right data structure for performance. The panel provides visual cues and reminders for robust, real-time filtering. After a pause to absorb the information, the user scrolls back to the top of the application. Finally, the user switches to Object, Keyed, Inverted Index Mode again, clears all filters, and resets the search input. The application now displays the complete, unfiltered product list, ready for further interaction, with the object-based strategy active for any new searches or filters. Now, you know exactly how to choose between JavaScript arrays and objects to build blazing fast, real-time search in your own front-end apps, without relying on heavy libraries or guesswork. This isn't just theory. These patterns give you tangible speed boosts that users notice instantly, whether you're building search bars, product filters, or dynamic tag selectors. By mastering these core data structures, you'll spot performance wins and architectural improvements in every project you touch. To keep leveling up with practical, proven techniques and real-world examples you can plug right into your codebase, make sure you subscribe. You'll stay a step ahead, turning every search feature into a seamless, instant experience for your users.